Okay, good evening or good morning for some of you.
Mhm.
Can
Hello.
you hear me? Does it sound okay?
Yes, we can hear you.
Cool.
Or I can hear you. I won't speak for
Good.
anybody else.
Thomas, I don't know how to say that. Your picture is very dark.
Yes, I was explaining earlier. I'm actually visiting my parents in Uganda, and this is their lighting in their
Oh,
house is very
okay.
low. Yeah, so I
No
apologize, but I
worries.
am here.
Okay, so we have a lot to cover today. Thank you for coming back, a second session, and also thank you very much for the feedback you gave me on the first one. Uh, I won't go through all the answers, but my takeaway are first, maybe the most important thing is try to be on time and to keep the session under 1 hour. So that's what I'm going to try to do. In any case, I personally have a little bit more time, so I try to put in this 1 hour slot what I expected to see, and if someone has any other question or anything that want to discuss, I'm really happy to stay online. In any case, I keep recording the session and upload it to YouTube afterwards. So what I'm proposing you today is maybe just have a quick look at the Trello board to see what was my view about how we could uh, put the different features into families very quickly, and then put the project on hold for this session and go to the JavaScript recap because according to the answers that the five of you that gave me, there are basically the level is okay, I think, but there are some things that I think it's important to review. Maybe you have some doubts or maybe misunderstanding or whatever, or want to cover a little bit more in depth some issues. But just before I start, just forgive me. I am an allergy to dust, and we've been cleaning the house, and I'm fucked up. So sorry about the voice and the nose. So okay, I'm gonna share really quick the Trello board and try to explain how my view is. Okay, so okay, you can see that. So my idea of the application is the following, and after that we can, after I expose my view, we can obviously disagree and agree and discuss about it in Slack to save time. Okay, so for me the app is all about the venues. User, as I already said, are secondary. So first we have to specify two focus for the venue. Sorry, in client point of view, I mean normal user point of view, and also from an admin point of view, meaning the owner or the manager of the venue. So basically, the app, when you get in the first time, you sign up, then you register, and then you just go to the main screen, which is the venue screen, where you can see all these features and maybe more on that. So those are more or less all the things that you can do to search and to checking in a venue owned by someone else. When you click on, when you select a venue, if you are the admin of this venue, maybe you have an edit button. When you go to this venue admin point of view, you go to this screen or this feature, and you can and you can reach all these features. Another family is the user onboarding. So user onboarding is just when someone get into the app for the first time, what can we do with it, or what can he does with the app? So yeah, he can register, he can just register online. Maybe he doesn't have any phone or computer at the moment. Maybe we can do this onboarding sort of offline, etc. Client identification, very easy. It's just a login page. When you get in, you get out. And user profile, very easy also. It's everything which is related to the user attribute. So name, email, photo, preferences, etc., etc. And then general aspect of the app. These are just features that are not in any specific categories because they apply through all the application or apply to some automated tasks. Okay, so it's not very for something specific, like maybe mobile friendly. It's not, you don't put it in a category of client, user, venue, etc. It's for everything. Okay, so that is my view. Next week, when we go through the charts, the diagrams that maybe you've done, maybe this will maybe take a little bit more an image more clear in your head. So we can talk about that on Slack if you want. But I think that you were most interested in reviewing some JavaScript stuff. So there are a lot to cover, so I go right into it. So 6 people are answered the questionnaire, the form. So please, if I'm gonna go very, very fast because we don't have a lot of time, and I would really like to have at least 5-10 minutes at the end for Q&A and whatever you want to talk about. So please just interrupt me, raise your hand, or interrupt me if I go too fast, or if there's something you haven't understood or whatever. Okay, so first of all, JavaScript is a compiled language or interpreted language. So most of you have answered correctly. I will be very brief. A compiled language is a language that goes through a compiler, which is a program that runs on your computer, and that generates a binary file written in machine code, just zeros and ones. Okay, so it's very different from an interpreted language or scripting language, could be also called, which is just a text file that you submit to another kind of program, which is an interpreter, an engine, or however you want to call it. That in this particular piece of code, the interpreter just execute what the script is telling him to execute. So it's very different. The big difference, there are 2 big differences. The first one is performance. Since the compile language just throw instruction to the processor, to the CPU, it's hundreds of times or thousands of times quicker than interpreted language that have to go to an interpreter or an engine to be translated, etc., etc. First big difference. Second big difference, interpreted language is platform agnostic. You just write it and it works everywhere. There is an interpreter available. Compile language is not the same stuff. You can write your code, but then you have to compile it on each platform. You have to compile it for Mac, you have to compile it for Windows, you have to compile it for Linux. It depends also on your CPU architecture. If you have an ARM architecture like in mobile phone, or if you have a x86 like in most computers, you have to compile for. So it's a pain in the ass to have compiled languages because you have to compile it for all the different platforms. Okay, so be clear. JavaScript is an interpreted language, like Python, for example, or like Python. So JavaScript can run in a web browser, directly on a computer, on a node engine, or all the above. So I just answered that. So to run JavaScript, we need some kind of intermediary interpreter or engine. So it cannot work directly on a computer. it can work on a web browser because a web browser has embedded a JavaScript engine. For Chrome, for example, it's called V8. Apple engine is called WebKit, I think. I don't remember Firefox. And Node, Node is very recent in terms of all the programming world. Maybe it's like 5 years old, or maybe a little bit more. And it's just the V8 engine from Chrome that have been rewritten in C++ and with some tweaks to make it work on any platform. So then you can run your JavaScript as without a browser. Okay. So far so good. Okay, I will consider okay.
Yeah.
Okay. Second one, JavaScript is a strongly typed language, loosely typed, function or procedural-oriented language, or object-oriented language. I thought this one would be easy, but it's not. So it's not a strongly typed language. A strongly typed language means that before you can use any variable in your code, you have to declare its type. And then once this type is declared, you cannot change it. So this variable, if it's a string, it will be always a string. It cannot change. And you are obliged to specify what kind of variable, what is the type of the variable you're gonna use. A loosely typed or dynamic type language like JavaScript is a language where you don't actually need to specify. Well, you can't actually specify the type of the variable. So you just declare the variable and then put some value in it, and then internally the engine will guess what kind of variable, what is the type of the variable you're using. So if it's a string, it will allocate space for a string. If it's a number, it will do so for a number. And then if you change the variable to something else, it will readjust and do it dynamically. Okay. Advantage and pros and cons. Obviously, strongly typed are more complicated to write, but they are more performant because they use the memory in a very more an efficient way. But loosely typed languages are very friendly because you don't really care about what's in the variable. But it could be tricky because you can have some bug because you thought there was a date in the variable and then there's a string or there's a number and then you have some errors, etc. And then JavaScript is a very specific, a very particular language because it's both a function-oriented language and an object-oriented language. You can do both. You can write JavaScript just without any function, without just instructions, nothing. You can write all functions, or you can write object. You can create object and classes and so. So you can do whatever you prefer. So this part I will stay a little bit and I will show you why, because it looks like a little bit nerdy, but it's important. So what is a primitive type? First of all, a primitive type is, let's say, the most basic type that the JavaScript can understand. So it is something that is, let's say, built in the system, and it's like the smallest unit of type. So primitive types are number, strings, boolean, null, undefined, and symbol. Null is is a strange thing because null is both a primitive and an object. It's both. Okay, so but let's say that it's okay as a primitive. And why is this very important to know? And I'm going to illustrate that very quickly. No. Present. Where is the? Okay. Okay, so you can see my screen, right? Can you all see my Visual Code editor?
Yes.
Yes.
Okay.
Yes.
Okay.
Yes.
Okay.
Yeah.
So let's do that. Sorry. I define a variable as a equal 10. Okay, so far so good. Then I define another variable and I say that b is equals to a. Okay. Then I change the value of a. So according to you, what's gonna get printed in the console?
I would guess 20. That's my guess.
Okay. Someone else? Is it consensus? Everyone is thinks the same. Everyone's agree.
No, it's going to print 10.
Okay. Anyone else?
Yeah, I think it would print 10.
Okay. 210, 120.
10.
Okay, so looks like 10. So let's run it. Okay, 10. Okay, but now change that. We change this. And if I run this, we have a different behavior. Okay? Did you see my point? So why is it that way? Well, the difference is when you work with primitives in JavaScript, you work with values. So each time you use a variable which hold a primitive type, you're working with the actual value of this type. When you work with something which is not a primitive, which basically is an object in JavaScript, then you work with the reference of this object. So I guess it's not very clear for everybody, or is it? Do you know what is the difference between byValue and byReference? Does someone know?
I think I do because it's like C++ related.
Well, yes, it's a very
Well,
global programming concept. Yes.
yeah, like should I explain
Yeah,
or?
sure.
So like I think by reference, instead of passing the value, you pass the pointer to the memory address, and the change occurs to the memory address and not like the instance of the variable.
Exactly. Exactly. So, sorry. I like to draw. So, do you see the Jamboard? Okay.
Yes.
Yep.
So,
Yes.
whoa, Siri. Okay, so we have variable a here for an object. Okay, let's say that a is an object. So here we have our memory, our computer memory, okay, which is represented by a grid where each cell is like a cell of a memory. Each cell has an address. Okay, so that's how the CPU knows where the data is stored. And let's say this is 0, 0, and this one is 0, 1, 0, 2, 0, 3, etc., etc. Okay, so let's say we have this value, which is 3 crosses in A. What we do is, what JavaScript does is store 0, 0 in A. So when we say B equal A, what we're actually doing is just putting the same address, the same reference in B. So B points to the same place as A. So when we change A, we actually change the data in the memory. But since B is also pointing to the same direction, its value also changes. Is it clearer like that? Or so that?
Yes.
Okay. So it's so this is very, very, very important because
Can I just ask something? If you go back to your drawing,
yep.
so let me try to say it kind of in my words so I understand. When you first say that so A was like an object, meaning it uses a reference,
Exactly.
correct? So if you say A points to that reference, that location 00, and then in my code, I change, I assign B, A to B, or I say B is equal to A. Now I'm saying that it's equal to that same location 00. So then if I go and change the value of B, the value of A will also change because A points to the same
Exactly.
location. Right? Okay, that's what I wanted to
So
understand. Okay.
as Harry said, is it's the same concept as pointer in C++ or any other language. So you're not storing, I mean, which is, for example, which is very, what is very, very efficient is if you have 100 variable that you assign one to the other, they all point to one direction in the memory, one address in the memory. So the actual value of this object is just stored once. So even if you have multiple variable reference to that, it doesn't matter. It's all reference to the same stuff, except for primitives where it's the actual value that is stored in the variable. That's why when we did b equal a and then we changed the value of a, b didn't change because it was a primitive, and it maybe it sounds a little bit too I don't know, complex or maybe too advanced, but there are a lot of bugs in your code because of that, because many times you get an object inside a function and then you think that this variable that you're getting from the function parameter, you can do whatever you want with it, but it's not true, because if you change it, you change also it changes also from the code that calls the function, so it could lead to really very difficult bug to identify. Okay, next one. What is the best way to initialize variable that might change in the future? Okay, a little bit of history. A very, very long time ago in a very far galaxy, people use var. We don't anymore. Okay, var is a huge pit hole of bugs and memory leaks. So never use var. Just use let and const. My recommendation is use const as much as you can, and if you can't, use let. So basically is when you're going to use a variable, when you need a variable, declare it with const, and then if you in your code you see that you're going to have to change the variable, then change const to let. Okay. There is a curiosity in JavaScript. Let me share the code again. Okay. So if I do that, it looks like I'm defining a constant called a, which is an object with one key or attribute called value with a value of 10. Okay. And since it's a constant, you can understand that it won't change because it's a constant. It's supposed not to change. Well, actually, it's not true. What this line says is I'm declaring a variable A, which is an object, and that's it. Then if I want to do this, it's still okay. Okay, but what I can't do is this. Normally I think it's gonna fail. Yeah, see. So I've declared A as an object, so I cannot change it and try to assign it a number or a string or whatever. But since it's an object, I can do whatever I want with it. So that's tricky stuff. So when you're working with arrays and an object, try to define them as const first of all, and then maybe, I mean, if you're working with object and you have to declare them as with let, it means that maybe it can change in the future. You're not writing your code correctly, and this will lead to bugs, because something that can completely change in your code is really misleading. Getting back to this. Okay, so var, forget about it and use just let and const. Set is not JavaScript. Well, it's more advanced. We're not going to see it today. So how do you instantiate an object? So most of you have it okay. So we just use let or const my object equal the curly braces, and you define an empty object. But this one is also true. Okay, you can define an object with the keyword new object parentheses. This will do exactly the same. It's the same. This one is wrong, and this one is wrong. You cannot mix the new keyword and the curly braces. It's new object, or it's just the curly braces. Okay, this one is very the dates chapter requires a full session. It's so complicated. So what concepts are related to JavaScript dates? So here the correct answer is the first four. The last one is not true. Okay, and let me try to show you why, or let me try to show you the other ones. I'm gonna go quick. Okay, just copy paste. So first you declare, or you instantiate a new variable as of type date. Date is an object. Okay, it's not a primitive. So D holds a JavaScript date, and we have many functions and methods on date to give us back the same value but different format. Okay, so if I run that, we have the value, which is this number, the local string, which is this string, the UTC string, which is this string, and the time offset. So why am I showing you that regarding in relation with the question? Because date are internally stored as number. Okay, it's the number of milliseconds since the 1st of January 1970 UTC, GMT, Greenwich. Okay, so this is the starting point. It's called the epoch date. It's the starting point of probably most of the computer systems in the world. 1st of January 1970s 000 GMT or UTC, same stuff. So the date internally it's stored as the number of milliseconds since this date, and that's what you retrieve with the value of function. So many times people ask, how should I store the date in a database, in Firestore or wherever else? And you can do it in many ways. I usually do that. I usually use the value of, but be careful, because this is the number of milliseconds in the 1st of January 1970 GMT in London. if you are in the US and you use this, you have to be careful to take into account the time zones, okay? And you have all these data here. If you see that, if I'm using the local, I don't know how to pronounce that, since I'm in Spain, it's 7:30, but the UTC is 6:30. Okay, so we have everything inside. So we both have, it's local related, it's a number, there's a time zone inside, as you can see here, it's GMT, and you can save it as you wish, but try to save it or as value of or as a JSON, for example, to JSON. If I do that, okay. So if I create a date and with 0 as a parameter, it means create a date with this amount of millisecond from epoch. And since 0 is epoch, so it creates the 1st of January 1970 at 000, and the Z means 0, means no time zone. So if you store that in a database, you can also create a date with it. So it works the same way. You can store the string or you can store the value.
Patrick, which way is
There's
the best
there's
one
no best.
to use?
Usually it's more efficient to save a number because it occupies less memory, but it's, I mean, with the current computer systems, that it doesn't really matter, except if you have millions of dates. Sorry. If you have millions of data and they charge you by bytes or by megabytes, it's much better to save a number than a string. But that's the only thing that, I mean, as you wish.
Okay. Because you have to parse it anyway before you present it to the user, right?
Well, actually, if you save this string, or if you save that, you can pass it. You can pass the value to the date function, and you get the actual date in return. Okay, so if you save that, you're saying this is a date. This is the date of the 1st of January 1970 at 00 Greenwich time. So if you instantiate this date with a date with this string, it will be correct. And if I do that, for example, let me change this. Okay, for okay, so the last one, as you can see, it says 1 a.m. because I'm in Spain. Okay, so you give him a parameter which is the date at Greenwich, but then you ask it, oh yeah, you ask it, give me this date, but in my time zone. So it converts it to your time zone. And since Spain is just 1 hour after London, then that's why it's 1 a.m. So if you store that string or that number and then you instantiate the date with this parameter, you're good to go. You will show to the user the date in his time zone. So it's respected. Obviously, 1 a.m. in Spain is the same as 00 at midnight in London. It's the same moment in the time, but the date looks different, but it's not different. It's the same date. That's why I say it's tricky. Dates are tricky.
Okay. Thank you.
Okay. So, and all the same, the date are the same for all users. That is not true. I mean, when you create a date like that, new date, blah blah blah, it just new date. The first one, new date parentheses. It just get the date of your computer. So, if my computer has one time and yours is 2 minutes ahead, then we have different dates. I mean, the dates are local. When you create a date in JavaScript without any parameter, it's not a global thing. It's just the date in your computer. So it's not the same for all the users. Functions. Which of the following doesn't declare a function? The first one is true. Is wrong. The first one declares a function. It's an empty function. Okay, so actually, no, sorry. You're right. The first one is not okay. The first one does not. It will get an error. This one is okay. This one is okay. This one is not okay, and this one is okay. Okay, so this is, let me copy that. Oh, I don't need to copy it. Okay, go back to the Visual Code. Okay. Function. So okay, let me copy paste for time's sake. So we have two functions. First function is, let's say, the traditional way of declaring a function. You just use the keyword function, then the name of the function, the parentheses. If you need any argument to your function, you put them inside the parentheses, and then you open and close the curly braces, and the body of the function goes inside. Okay, nothing really fancy there. JavaScript allows another syntax, which is called a sugar syntax, which is just to write the same thing in a different way. You just assign a function to a variable, and then you have the same, exactly the same thing. So if I do type of my function 1 and my function 2, okay, 2 times function, both are the same. Okay, both are functions. And now also I can do my function 3 new function. It's also a function. Okay, so you have three ways of declaring a function. The last one is completely useless because you cannot declare a body. So it's not used anyway. So this one is important when you use callback. Then this is called the arrow function notation because of the arrow over there. So let's say, let's put another one. Okay, when we put some arguments. So you already know, I guess, because of you tried, you can do also that. Okay, this is correct. Okay, so instead of having parentheses, we just put the variable that the parameter of the function we need to pass to it. So if I call this function, I mean, this is nothing new. Blah blah blah, and I run it. Okay, and if you want to pass several parameters, you have to get back to the parentheses. And okay, then we have it. So next step is, let's see. Oh, I forgot to mention the arrays. Okay, that doesn't matter. Are you all familiar with the for each or the map operator with arrays, or is there someone that doesn't know how these operators work? No, you all okay with it? Okay. So let's declare an array like this. Okay, then I can do this for each, and as you can see in the description that the IntelliSense that Visual Code gets you, for each, like map or reduce or all these, or filters or sort or all those functions, they require another function as an argument. And when a function needs another function as an argument, it's called a callback function. It means that when the first function is called, is executed, it's gonna delegate the execution of its code to the function you provided to it, okay, with some values. So here you can see the actual form or shape of the function the for each method is expecting. So it's expecting first a parameter of type value, then an index, and then an array. So we can do that. We can do value index for the moment, and then an arrow, and then again value index. Okay, so I'm gonna get rid of this one, and then you have it. Okay, so first it prints the values, and then it prints the index of these those values in the array. But this is very simple, because as you can see, this line here is the same shape as my function 3. Okay, can you all see that? This is the same function. Well, actually, it's not exactly the same. If I can write this. So if I select all these, value, index, blah, 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 it's exactly the same as this one. So what I can also do, well, I'm gonna put it here. Instead of using this function inside, I can call my function 3. But as I said at the beginning, for each is expecting a function as a parameter. It's not expecting the result of a function. So you don't put the parentheses with the parameters. You just put the name of the function, because that is what for each is expecting. Okay, so if I run that, I have exactly the same result, except that we are running my function 3, so we display this line. Okay, is it okay? Are you all following along?
Yep.
Okay.
Yes.
So it's important because, for example, when you do unit testing, the thing we had before, this is called an anonymous function. Okay, so we have a function, but we haven't given any name to it, so we are not able to use it anywhere else in the code. It's just executed there in the for each, but I have no way to reference this function anywhere else. I don't know how to call it. It's anonymous. So the issue is when you do unit testing, sometimes in very complex code, you want to avoid anonymous function and declare them outside to be able to test them in a unitary basis without the for each. If you just want to test my function 3, you can test it and then you can use it there, so you don't have to unit test it again and again. So we're very used to use anonymous function in JavaScript. What else? Okay. One curiosity, I'm not switching back to the questionnaire, the form. There were a curiosity about arrays. So let me get back. This is my array. So my question was, how could I add a new element to the array, which is basically very, very easy. So append is a Python keyword. It's not working in Java. So it's push. So you push a value in your array. So there you go. Now we have 4 values. So we push means we append it at the end. Okay. So everybody had this one okay. But the other ones were, well, they were a typo actually in the question. So probably you all answered correctly. But my point was, can I do let's forget about the push for the moment. So I have an array which is a constant with 3 values. So can I do this? Sorry, it's 0 based. So can I do this?
Yes.
Okay, so this
Yes.
is position 0, position 1, position 2, and I'm creating a new position 3 with a value 4. So it works the same as push, except that you have to know where you're putting the value. But can I do this? So my array has just 3 elements at position 0, 1, and 2. And I'm trying to set the value 10 at position 9. Am I allowed to do that? And if I am allowed, what could be the result of that? What do you think? No clue, no idea?
Will the index in the middle be null?
Almost. They will be undefined.
Okay.
Yeah. So then you have, but you have now an array of 10 position of 10 values, which are 1, 2, 3, a lot of undefined, and then 10. So you just increase the size of your array from 3 to 10 with just one number. Okay. So you need to be careful when you use array not to get array very big, because then when you iterate, you have a lot of undefined, which are usually complex to deal with. So we still have, I think, okay, question what we have. Anonymous function is a disposable function. Obviously, it's disposable. It only exists inside the function or method that called it. You cannot use an anonymous function anywhere else in the code because you have no way to reference this. And anonymous functions are mostly used as, I don't remember the question, as asynchronous or what? I don't remember. Dates function as callback. Yes, anonymous function are mostly used as callback. And the question: arrow function are more efficient than traditionally declared function? False. It's just a syntactic trigger. It has absolutely no effect on the performance of the code. It's just a quicker way to call it, to write it. Callback functions are mostly used in synchronous situation. You all answer false, and it's not true. It's true, but it's also used in asynchronous. It's called in synchronous the way I showed you. When you call map, when you call for each, there's many functions that use callback functions, not only asynchronous. It was just for fun, nothing. But usually, obviously, for asynchronous purposes, you have to use callback or something else. Next question was, what is the callback hell? And some of you have answered correctly. Let me try to see where the answer is. Here, it's here. I don't know what I'm showing. Okay.
We're just seeing your VS Code right now. Okay.
I have so many tabs. It's here. Okay. So callback hell is exactly that. Okay, so it's a function which results will be given back to the callback function, and then inside this callback function you also have another callback function which is also calling another callback function, and then you have multiple nested callbacks, and it's a nightmare to debug. You never know who is calling who and where you are in the code, and obviously it's most of the time it's all asynchronous, so it's really hard to debug. So this is why I ask the next question, which is, what tool or object has been created to substitute callbacks? And some of you answer the async await. This is the good idea, but actually it's promises. Async await is just a way to deal with promises in a, let's say, easier way. But actually, it's promises. So promises are a better way to work with asynchronous operations. So it's 10 to 8. We still have classes and promises, which are probably the most complex stuff to do. I'm not sure we should go for it right now. I don't know if you prefer, maybe you have some doubts on or question on everything we've seen up to now, and I can answer that. Or if you have any other question, I would not like to go directly into classes and promises, because it's the basic of everything we're going to do after that, because everything is based on classes and promises or observable, which are sort of a promise. So we need to understand and to take our time to see that. So if you have any question or any feedback or whatever, I'm an open book. Or maybe something about something we haven't seen right now in this hour.
Hey Patrick, I have a question. Talking about arrays, why would we want to expand an array by a certain amount? Can you make like a real case scenario sort of example?
You mean you start with an array of 3, but you need an array of 10 every time?
Yeah, why would you need to push something to the 10th position in an array?
I don't know.
Keeping a bunch of items.
Probably you don't do that on purpose. What you might do is in your code, instead, let me share the screen. Stop here and share that. So you have your array 1, 2, 3, and then you do something in your code in a function somewhere that you don't remember where. You do something like this. You actually don't know what n is. Maybe this line is inside a function that is called by another function, which is called upon a trigger about something else. You don't know. And then n can have any value. Okay. So this is not really good code if you just do it like I just said, because you don't know if you are overwriting something or if you're basically putting this value at an arbitrary place or position in the array. So you have to be careful what you do. So I just wanted to illustrate that you could, for example, in many other languages, you cannot do that. Or you can push, or you can append value at the end, 1 by 1, or you can substitute the value or already existing values, but you cannot suddenly put a value in a position that didn't exist before, because how memory works or memory is managed in Java or in C or C++. There's no way to do that. JavaScript allows that, and it's cool if you know what you're doing, and I cannot think about a use case for that, but it's also a danger if you're not controlling what you're doing. So usually it's a mistake if you do that, because nobody wants 1, 2, 3, then a lot of undefined, and then an actual value there. I don't know of a use case for that.
Okay, thank you.
Did you say that there is no difference between map and for each, or do they have slightly different?
No, I haven't
It's
said
exactly
that.
the same.
No.
Oh, you didn't say that,
No.
because I was going to ask
No.
is there a difference?
The question in the form was because I've seen a lot of time people do that. They do. Okay, so then I have my value, and here I do array 2 push value by 2. Okay.
Mhm.
Okay. Sorry. Okay. So the syntax is correct, but this is not the way it works. If you need a second array from the first array, applying some modification, you don't have to do that. This is more a for each stuff. Okay, this is, whoa. Okay, this is for each. Okay, this is the most correct way to do it, because for each doesn't return anything if you use, but this is, let's say, because we are coder, we are lazy. That's the definition of a coder, first attribute of a coder. So what you should do is this.
Okay. You wouldn't be able to do this with for each
No, you cannot return anything with
because
for
it
each.
doesn't return.
For each is just it's a procedure. It just does some stuff, but it's not returning anything.
So that's why you need the array already declared, and then
Exactly. You
you're
have to
pushing
declare it
things
first,
into
then
the
you
array.
iterate
Okay.
on the first one, and on each loop you do something with the value. So, for
Got
example, you push it to the second array. But with map, you have to write a lot less code. The map iterates upon the values of the array. They give back the value parameters to your callback function, and what your callback function returns will be put inside the new array. So this yields the same result, but it's a lot less code and it's much more readable.
Got it. Thanks.
Okay, so this is something I see a lot of time on code. People using map as for each. They declare the stuff on top and then push it. It doesn't make any sense. Just use map. You can, because map returns an array. You can map it again if you want. Okay. Since the return value of map is an array, you can still apply array method to it. So you can map it, filter it, or whatever you need. Okay.
Thanks. That was helpful. This was all very helpful, by the way.
Okay, I don't know. It sounds so basic to me. I'm not sure it's interesting or not. But many of you asked, well, maybe all of you have asked to do a recap on all those concepts.
Yeah, I think the quiz just helped me to see some gaps that I had or things that I was making assumptions about that I just need to clarify a bit. Because, like you said, that's sometimes how you get an annoying bug that you just don't know what's going on, but it's because you're missing some fundamental understanding.
Sometimes, yes. It happens to all of us. The primitive stuff is usually a big mistake. You just assign an object to another variable and change the parameters, and then nothing works, and you don't know why. I don't know if I made my point clear. If you do that, okay, and then you do that. No, my function a see what I've just done. I declare a as an object with a parameter called value to 10. Then I declare a function to which you have one parameter, and then this parameter get the key value and assign the value 3 to it. So you say, okay, I want a new object called b, but instead of having 10, I want 3, because this is the goal of my function. But what you're actually doing is also changing a inside your function, because param here, which is a, is an object. So you always passing it as a reference. So here param is a reference to the same memory location of A, and you change its value. So you change the value for all the references of this memory spot. So this is where you have many bugs. Because param is not a copy of A, it's actually A. So if you change its value, you change the value for A also. Okay, so to do that, you have to use the spread operator or deep copy techniques. It's a little bit more complex. So this is the very, very common bug. Okay, it's 8:01. I promised I will be sharp on time. For those of you who haven't much time for a break for this session. So please feel free to leave if you have to, and I can still be here for half an hour if you need so. I'm really happy to help any question, to answer any question if you wish. If you have time, obviously, I'm glad you stay.
Hi Patrick, I got a question.
Yeah.
So when you're talking about the creating functions, you mentioned arrow functions. Should you always be using arrow functions, or is there a sort of time and place to use an arrow function instead of a sort of normal sort of function?
It's a question of taste. If it's preferences, if you like.
Okay.
I mean, usually, if you let's say, well, let's get back to our. Well, So usually what you type with the map function, for example, which needs a callback function, you usually use an arrow function and the shortened version, which is directly this. Okay, so this is probably the most condensed version of the arrow function. This here means declare a function that takes one parameter that you call value and then return value multiplied by 2. Okay, so this thing is the same thing as those are both they both do the same stuff. Okay, they perform the same way and they do exactly the same thing. The difference is it's much quicker to type, and it's easier to read also, no?
Awesome, thank you.
So it's really a question of preference. If you need a more explicit version, so you can use the function, or you can even declare this function outside of the map and then use it in the map, etc. Or you can just use that. Okay, but it's as you wish. Convention usually for all the callbacks, they usually use anonymous function. There are two reasons for that. First one, it's more readable. Second one, if you use an external function, I mean, if you do that function, my function, and then use it here, then it's not an anonymous function anymore. It's declared here. It works the same way. The difference that now my function is stored in the memory for all the scope of this execution. So if this is in the main loop, you will reserve memory for this function, and you will probably just use it there. So it's a little bit of a shame to waste your memory in storing something that you don't need. You just need it here. So in this case, this is why you use anonymous function. You don't declare them outside. And a more readable way to use anonymous function is to use very condensed arrow functions. Okay. If you have, do you have 15 minutes? Does someone doesn't have 15 minutes? No? Okay. So we can.
I'm fine with
Okay.
15 minutes, yeah.
Okay, so we can do classes. Because promises are a little bit more complex. So, classes. Let me copy paste. Okay, imagine this is very basic. Okay, this is just to illustrate. Nobody will do that in his sane mind, but just to illustrate my point. Imagine that you have an app and you have to obviously store the user data inside your application, and you don't know how to do it. So the first thing you can do is, okay, I'm gonna hard code the user. So I create a user object, okay, with the curly braces. I give him some properties, an ID and a name, and then I define some functions, okay, so a logging function. As you can see here, I'm using the arrow function and I'm assigning this function to a variable. So now login is a function and a logoff function. Okay, and in the login function, as you can see, we need to display the ID and the name of the user, but there's no way to use the internal parameter, so we have to reference the variable that we declared the first time. So it's a little bit complex, but it works. Okay, so let's say now user dot, and you say, as you can see in the IntelliSense, then the Visual Code recognize everything. So I can call login. So if I run that, okay, I'm logging in with ID 0 and name Pete. Okay, because ID 0 and Pete. But now you have another user and maybe 1,000 user. You can't hard code all the users. Okay, it will be crazy and it's almost impossible because you don't know who the user are. So they must have them. There should be a way to do that in a dynamic manner, and this is where classes come in. So the way you define a class is obviously with the class keyword. Then you give a name to the class, and by convention a class must be in Pascal case, meaning that it must start with a capital letter. Then we have our two functions, the login function and the logoff function, and then we have something called a constructor. Okay, and it's very easy. Constructor is just a keyword, so it's the way you tell JavaScript how should I build this object. And here what we are saying is that to build a base user, an object of class base user, you have to pass it two parameters, the ID and the name. And what the constructor does is assigning these parameters. Okay, let's call ID1 and name1. Okay, just for it not to mix both the two of them. So this variable will be assigned to this, and this variable will be assigned to this. So what is this keyword here? Well, in JavaScript, this is a reserved keyword, and it means the thing you are working inside, you are working with. So here we are defining a class. Okay, so this refers to the class. So what I'm doing is, when you construct this object of class base user, you give me two parameters, and what I'm going to do is create two properties of my class, one called ID, one called name, and I will assign the variables to these properties. Okay, that's it. There's nothing else to do with classes, to create classes. Sorry. So now you can do Joe. Sorry. And as you can see, if I trust IntelliSense, it tells me that to create a base user, I have to pass it an ID and a name. Okay, so ID1, and name Joe. And now I can do Joe login. See the difference now? ID as a little box, a blue box, which is a property, and login and log off are a little bit a cube, purple cube, which are functions or methods or procedures. So I can still do login. And now here you go, logging with ID 1 and name Joe. Okay, so this is why you use classes. When you need something to be structured, and here it's very, very easy. But maybe you want to define a class. When you log in, you're actually logging into some database or retrieving data from the server or whatever. You can do any complex operation inside your class. Okay, and you just have to describe it once, and then you can instantiate as many objects as you wish. So we can oh. Okay, so this is something very useful. So far so good, or any doubts?
It's good.
Okay. So the next thing, which is very interesting, is inheritance. Okay, I'm gonna get rid of this. And now okay, so let's say that this is your base user. So this is your base user class. So it has maybe the most fundamental properties and functions that you can require, but maybe you need a more advanced user. So you could create, for example, a Google user. But a Google user, if you want to do one, it has to have the same properties and methods and everything as a base user. But you don't want to repeat yourself and rewrite everything. Remember, dry, don't repeat yourself. So a way to do that is to extend the base user class. That means that the Google user class is based on the base user and will extend stuff. So it will have everything that the base user have, and also put some new info inside it. So first we have to create a constructor. Since we are based on the base user, we have to pass the same parameters as the base user. And we can put some more. And there is a specificity for extended classes is the keyword super. Super means since you are extending the base user class, when you construct the new one, the Google user class, first you have to call the constructor of the base class of base user, and this is done with super. Okay, so you can see that if I tap super, IntelliSense recognizes that I'm actually instantiating a base user class. So it's asking me to input the ID and the name. So I have these parameters over here. That's it. And now I can do that. Okay. And now I could put some very complicated call to the Gmail API and retrieve all the messages from this user. Okay, so let's say here, and now I can say that Fred equal new Google user to Fred, and now you can see that Fred still has the logging and log off function because they inherit from the base user. So it can log in, but it also can show my messages. Okay. So we have extended the base user class to create a new one, and we have put more functionality, more features into it. So you can extend without any limits. You can extend multiple classes, you can extend many things. This is called inheritance or polymorphism, if you maybe have heard of this word before. Question on this last one.
Yeah, I have a question. So in line 43 and 44, when you do thread.login and thread.show messages, is there like any, will there be any time where we'll need to pass any arguments, write anything between those brackets, right? Like after login and show messages, will we ever pass any arguments between
well, since we have declared it without any parameter, you don't. But if you do login, yeah, and here you say, I don't know, username and password, then here you will have to pass these two values. But it depends on how you declare your function. Obviously, for a login, you will probably have to pass that.
Okay, thanks.
More questions?
Could you explain the constructor and super again on line 31 to 33?
Okay. Yeah, this is not obvious. I get back to the base user. Okay, so this is the constructor of the class. So what that means is to build an object. A class is like a blueprint. Okay, so to build an object of type base user, the JavaScript look for the constructor to know or to require from the user which parameter it has to pass. So in this case, we define a constructor with two parameters, ID1 and name1. Okay, and then we do stuff with it. Doesn't matter what. So JavaScript, when you do a new base user, automatically it says, if you want to build this class, you have to give me two parameters. Okay, the ID1 and name1. This is how you can build a base user class. Okay, so far so good, no? When you extend this base user class into the Google user class, you also need a constructor. You always need a constructor. But since you're basing your Google user on the base user class, you have to construct it with the required parameter of the base class, of the base user class. So you have to have the ID and the name, because the base user class, which is, let's say, it's like a tree. So the first layer is the base user, and then you build on top of it. But at the end, the requirement of the root has to be fulfilled. It doesn't matter if on top you're adding more stuff. The base level has to be fulfilled. So you have to get these two parameters, and then you can ask for more. You can ask the constructor to ask for more parameters for the Google user, but you have to respect the contract of the base user class. And now, so you have to do that. And the super is, okay, this class is not, it's not the first level of the hierarchy. It's based on base user. So first, to be able to instantiate a Google user class, first I have to instantiate its owner or its parent. And how do you instantiate the base user class inside this? Using the code super. So super ID means when you want to create a Google user instance, you need to pass this parameter in the function with first I will instantiate my parent, which is base user, and then I will do stuff with the data. Okay, so this is, you cannot omit this line, because it would mean I am trying to instantiate a child class, so a class descending from base user, without having any parent. So I think there's just one guy in the whole world that has, a weird stuff with no parents and is born. It's called Jesus. So there's no way you can be born without any parent. So you have to create the parent inside the child and then use this value.
Okay, awesome. Thank you.
It's hard to explain. I don't know if I'm clear.
No, that makes sense.
Okay. Any more doubts? No? Should we leave it here? Okay. I take that as a yes. Okay, so let me think. We still have promises to see, and will take probably 20 minutes or half an hour if we don't go too fast. And I think it's much better to take our time. So we could do that next lesson. So we can part next session in two. We can finish with promises, and the other half of the session we could get back to the app and discuss about the workflows and what we've seen in the Trello. Is it okay? You find it's a good approach?
Yeah, that sounds good.
Sounds good.
Yeah. Cool.
Okay. Well, if I have anything in mind during the week, I will send some message in the Slack channel. Okay. Well, thank you very much for attending again.
Awesome.
Patrick.
All right, thanks,
Have a
Patrick.
nice day.
Have a nice week.
Take care.
And have
Bye,
nice
guys.
Christmas.
Merry
Yeah,
Christmas.
Merry Christmas, everyone.
Yeah. Bye.
Happy holidays.